All right. We're going to do difference of squares here real quick. This is Algebra 2, Semester 1, Unit 3, Bridge Math, Semester 1, Unit 4, Algebra 1, Unit 2? Semester 1, Unit 2, maybe? Maybe Semester 2, Unit 2, I'm not sure. Anyways, difference of squares. Start with the formula. We have a squared minus b squared, and that's equal to a plus b, a minus b. So it's the same two numbers, and we flip them. So difference of squares is looking for two terms with a subtraction sign in between them. So I start with x squared minus 25. We have two terms. They're separated by a minus sign. And what I'm going to do is I'm going to take the first piece, which is x squared. I'm going to call that a squared. So I'm going to say a squared equals x squared. All right, so that makes sense. First thing is a squared. I'm going to take the square root of both. Square root of a squared, square root of x squared. That's a equals x. Do the same thing for 25. I'm going to set it equal to b squared. So b squared equals 25. I square root both sides. I have b equals 5. So I identified my a, identified my b. And now I'm going to plug it back into this formula where it's just add your a's, add your a and b, subtract your a and b. Ends up being x plus 5, x minus 5. Now remember, this only works if we have two terms separated by a subtraction sign and they're both perfect squares. If they're not perfect squares, we can't do this. Do it again here for x squared minus 100. I'm going to say a squared equals x squared. Solve it again. Take square root of both sides. I have a equals x. The second piece of it I'm going to call b squared. B squared equals 100. I square root both sides. B equals 10. And then it's just x plus 10. X minus 10. Real quick here, going to the other one. Let's do one that doesn't work. We'll do x squared minus 8. A squared equals x squared. I square root both sides. My a equals x. B squared equals 8. Square root both sides. B equals, well, that's going to be 2.8 something or other, right? It's not a perfect square, so we actually can't do this. All right, so because the 8 wasn't a perfect square, we actually can't do it. All right, we'll do a couple more examples, a little bit more complicated and ugly looking here. We have 4x squared minus 16y squared. There's more to it. That doesn't change how we do it. I take a squared, and I set it to be my first thing. My first thing is 4x squared. I take the square root of both sides. A equals, the square root of 4 is 2. The square root of x squared is x. A equals 2x. B squared equals 16y squared. Square root of both sides. Square root of 16 is 4. Square root of y squared is y. And it's 2x plus 4y. 2x minus 4y. At any point during this video you don't understand anything, please pause the video and talk to the future Mac who's going to be in the classroom with you. Pause it and talk to him. Past Mac can't help you. Was that funny? I thought it was pretty good, right? All right, do one more example here. Bring my computer out. That's kind of cool. You gotta ask future Mac, right? Because current Mac ain't gonna be there. Isn't that Rick and Morty kind of idea? Like there's different. Anyways. All right, a squared equals 25x squared. All right, same idea. X squared root both sides. A equals 5x. Now the b squared is even more complicated because it has two variables, a squared and y squared with the 81. I square root both sides, and I just take the square root of each individual piece. The square root of 81 is 9. The square root of a squared is a, and the square root of y squared is y. So it's 5x plus 9ay, 5x minus 9ay. So if you notice, we're really just trying to get the square root of the first and the last and put them together with addition and subtraction. Again, if you have questions, something that makes sense, please pause this video and call the current Mr. Mac. I'm probably wearing the same shirt, let's be real, and see if I can help.